Normally, when you want to find a measurement of something, you can grab a ruler, or you can perhaps use a map, and that map will tell you the distance. But what we're learning today, or what we're starting to learn, has to do with distances when you're dealing with points in a coordinate plane. Okay? Take, for example, the point 1, 1, which I've just graphed there, and the point 5, 3. These are mine, these aren't in the book. Okay, so this is 1, 1, and this is 5, 3. If I asked you to tell me the distance between those 2 points, you could say to me, well, can I use my ruler? No, you can't. Well, what can I do then? Okay, that is where this awesome, awesome formula comes in handy. Now, I know you don't like formulas, folks, but this is going to be it for you for the rest of your math career. You're going to have to start learning ways to plug in information, okay? Ways to figure stuff out. This formula is going to help you establish the distance from the first point to the second point, okay? The distance formula, and it's in your book, but you're going to want to write it down, you're going to want to refer back to it, is defined as the following. The distance, and that's between the points that we're talking about, so in this case it happens to be the points that I graphed there, is equivalent to the square root of x2 minus x1 squared plus y2 minus y1 squared. What on earth is she talking about? Well, I'm going to clear that up for you here in a second. Okay, if you want to call this the first points, like the first coordinate pair, and this one the second coordinate pair, thereby being the second set of points, then when you are finding the distance between the two, this is defined as the first x point, also stated x sub 1, and the one next to it is the first y point, also known as y sub 1. For that same reason, this one is the second, and that's the second, okay? So that's where this information comes from, okay? How you doing so far?
Could we switch her around and make the other one?
Absolutely.
The other 1.1?
Absolutely. As long as you choose this to be one set of pairs and this to be another set of pairs. It doesn't matter. You could have said that this is going to be the first and this is going to be the second, just like with slope. It'll still work. That is an excellent question, and I will show you some examples of that. All right? So knowing this little piece of information, again, this is not in your book, but we are going to find the distance between my points A and B. Okay? Okay? Slide that up a little bit. Just a little bit, though. So, in order to do that, I am going to plug in my x sub 2 point here. Okay? Equals square root of parentheses, parentheses squared plus, please build your charts like this. So, my x sub 2 point, which is the 5, is going to go right here. Everybody see that? Okay, my x sub 2 point, which is the 5, has gone here. Okay, minus my x sub 1 point, which is the 1, is going to go here. Okay, Does anybody have any questions as to why I put what I put where? Over here, the y's. Y sub 2 goes first, which is this one. Happens to be the 3. Following along, the minus, 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 my y sub 1, which is the second piece. That happens to be a 1. Okay? So we filled in our x points, we filled in our y points. From here, we can actually calculate. I'm going to slide it up a little bit. 5 minus 1 is what, folks? 4. 3 minus 1 is what, folks? 2. Okay, you see how I'm kind of building an answer? Okay. What's 4 squared? What is 2 squared? So far, so good? Simplify where applicable, unless they tell you to evaluate to the nearest integer. If they tell you to evaluate to the nearest integer or solve to the nearest whole number, then you're going to put that into your calculator. Okay? But I'm telling you to simplify. So I'm going to factor it and find my greatest perfect square factor, which is that. Pull out the square root, and the answer is 2 radical 5. In other words, I can also say 2 times the square root of 5, which is going to be approximately whatever Justice tells me it is. 2 times the square root of 5 would be...
2.2360.
Say it again.
It's a little bit blurry, but it's like 2.23, and then I can't make out the rest.
2.23. I've got 4.47. 2 times the square root of 5, 4.47. Okay, so if I ask you to simplify, you're going to give me that. If I ask you to give me a number to the nearest hundredth, you're going to give me that. Okay, does everybody see the difference between the two answer types? Okay, if it says simplify, this is what you give me. If it says to the nearest hundredth, you'll give me something like this. So, in other words, the distance between the two is 4.47 units, or 2 radical 5 units. All right? This is very similar to their example 1, top of page 477. Okay? Obviously, as you copy these and do these with me, it gives you the practice you're going to need to later recall how to do this so that you're not completely lost. Example 1, find the distance between points M and N. Notice they did not graph them, they're just giving them to you. All right. The distance formula is the square root of x2 minus x1 squared added to y2 minus y1 squared, okay? They have identified the second point, the letter N, as being the 2, okay? Justice, you with me? Justice asked, what if we make this 1 and that 1 2? Will you get the same answer? Okay, the book has this as being the second point, that as being the first point. Let's flip it around and see if we get the same answer. Okay, so we're going to call this x1 and that y1, and this x2 and that y2. Okay, so this is the second point, this is the first point. I am showing you this so that you see that it doesn't matter which point you name as the first or the second. Okay, so x sub 2, what numeric value is x sub 2 based on my labeling? Can anybody see it? Brooke, what's the numeric value for x sub 2? Whoops. So you see me pointing to it right there. x sub 2, what's the numeric value for x sub 2? You see me pointing to it right there. What's the numeric value? Bravo. Do you see that? Okay, so here's x sub 2, and in the first spot, we're going to put a 6. Why? Because that's where x sub 2 goes. And I have named this x sub 2 because I want to show you that it doesn't matter which pair of points you make points 1 or points 2. Okay? X sub 1. Can someone tell me what x sub 1 is? Go ahead. 5. He's right. Okay, does everybody see? This is x sub 1, x sub 2. Why? Because I just happen to call it the second pair of points. This is x sub 1. Why? Because I happen to call it the first pair of points. What is y sub 2? Hannah, y sub 2, based on my writing. 3 is right. And y sub 1, Mr. Burrell? 7. Okay, so 6 minus 5 is 1. Let's square it. 3 minus 7 is negative 4. Let's square it. Right now, I would like you to compare this to the third level in the book's sample. Notice that it's numerically the same, only the signs are different. It won't matter, though, because when we square a negative, we get a positive number anyway. That's why it works. So 1 squared plus 4 squared is going to be 16, right? Plus 1 is 17. So the square root of 17 is the distance. Can that be simplified, despite my big long line? No. It's a prime number. No perfect square factors can be pulled out. All right? So, step 1, name your point. Decide which one is going to be the first one and which one's going to be the second one. Oftentimes, I choose it based on the ease of subtraction. Okay? And you can do that. Or you choose to just do it in the order that it's listed. MN. I flipped it around so that you could see that it'll work either way. Okay? Let's do checkpoint number 1 and 2. We're almost done with today's lesson. So checkpoint number 1, find the distance. Everybody's copying this with me, correct? Yeah? The points are 11, negative 2, and 7, negative 5. Do you want to call this the first one so that these are the sub 1s and this the second one? How do you guys feel about that? Let's do it that way. Okay? So just for a real quick reminder, this is the x, right? This is the y. And since this is the first point, this is x1 and y1, just to identify it with which point it goes. Since this is the second point, this is x2 and this is y2, because this is the second point in our list. And we're finding the distance between the two. Distance point is equivalent to the square root of, and every single time I do this, I have to look. So don't ever think I'm going to expect you to memorize this. If you memorize it, great. But for some reason, I have a block. I have to just keep looking. Okay. The distance between 2 points is defined as the difference between both x's squared added to the difference between both y's squared. That sums square root. That's the distance. X sub 2. Ben, where's x sub 2? What number?
7.
Great, very good. And x sub 1. X sub 1, Brandy Lou, what's x sub 1? Say again? 11? Good. This fan just kills me. I have such a hard time hearing, so I apologize. I just can't hear good. All right, y sub 2. Where's y sub 2, Jen? Where is y sub 2? As you see me pointing to it, if you are looking on the screen. What kind of 5? Bravo. And y sub 1. Y sub 1, Jada. Yes. Now this is where it can be tricky. I did this so that you can visualize it, okay? So 5 minus a negative means you add the 2 to the negative 5, okay? Removing a negative is adding the opposite, okay? So let's do that first piece. The 7 minus 11, what is the difference between 7 and 11? 7, 8, 9, 10, 11, it's negative 4, right? Negative 4 squared, okay? And 5 and that, so that's a negative 3? Everybody good so far? What's 4 squared?
16.
Added to 3 squared.
9.
The sum of that is what?
85.
What's the square root of 25?
5.
Distance is 5, and we're going to say units because all we're talking about here is distance on a coordinate plane. Okay? Distance on a coordinate plane. We name one point, point 1, we name one point, the other point, point 2. The x value for point 1 is x1. The y value for point 1 is y1. The x value for point 2 is x2. The y value for point 2 is y2. You choose which point is 2 and which point is 1 because it won't matter. Okay.
Why didn't you keep the sign for the negatives?
I did. Hold on, let me get it back. Hold on.
What is this negative 4? Is this in power? Negative 10
Yeah.
Negative 4 squared is positive 16. Yep. Good question. All right. Let's go into Scott Stauffenberg's journal. Okay. Here we go. Let's do checkpoint 2. Checkpoint 2. Everybody should be doing this with me. If you're not doing it, I guarantee you won't get it. The points are, for checkpoint 2, negative 1 and 3, 5 and negative 2. Did you all list these? Which one would you like to call the first point? First one? Make it easy? How about that being the second point? So that means the points x and y here belong to the first ordered pair. That means the points x and y here belong to the second ordered pair. Okay, any questions on this so far? Okay, distance formula. You're copying it with me, right? Square root of x2 minus x1 squared added to y2 minus y1 squared. Distance between 2 points is defined as the square root of the sum of the differences between the points. Okay, so let's start plugging in. Class, what is x sub 2? Good. And what is x sub 1? Yeah, be careful. Look at how I'm doing this so that I don't screw up. Okay. Y sub 2. Y sub 1. Okay, I found the points based on which points we chose for 1 and 2. Plug them in. Make sure that you recognize that this subtraction sign still exists even when the number for x sub 1 is a negative, or if the y sub 1 is a negative. That subtraction sign is separate from the subtraction, the negative value of the number. 5 minus a negative 1, so that's 6, right? 6 squared. And this is a negative 5, am I right? Negative 2 and a negative 3? Negative 5? So 36 plus 25? Ugh. So 61? Are there any perfect square factors of 61? No. Therefore, the answer is radical 61 units. Okay. Before you do quit, ask yourself, are there any perfect square factors? Go ahead, question.
Just a warning, because like I did it ahead and I got it wrong. Just don't.
Listen.
Just make sure that you're not doubling it, but you're multiplying it by itself when you're doing the square.
He just reminded me of something that is a very good point. 6 squared isn't 12, people. Negative 5 squared is not 10, whether it's negative or positive. Okay? When you square something, you are multiplying it by itself. And you know what? I go back to that all the time where I'll follow that up. Okay? Good thing to remember. All right. Using the distance formula can come in handy. Take a gander at example 2. Just because it's a word problem doesn't mean that it's difficult. Example 2. Those of you that are interested in some bird watching. A bird watcher uses a grid to photograph and record locations of birds as they feed. He uses a grid made of fishing nets made of strands that are a foot apart. So it's like a graph that he overlaid onto the ground. Okay, each distance is a foot, so each unit is a foot apart. Each point represents the location of a bird. How far apart are A and B? Okay, coordinate of bird A. Coordinate of bird A. Sadie, what's the coordinate of bird A?
3 and 2.
She says he is 3, 2. Love it. How about bird B? Bird B, Dylan. Give me the B's coordinates on page 477. Michael, you want to help him? Where bird B is? He says B is 7. Sorry, I can't hear. 7, 5. See? He's right. So let's call this A, the first pair, the first set of points, and we'll call B the second set of points, which means that's X1, that's Y1. This is X2, this is Y2. Plugging them into the distance formula. The difference in the X values squared added to the difference in the Y values squared, that item's square root. X2, can someone tell me what X2 is? 7. And X1? 3. And Y2?
5.
Good, Y1? 4 squared, 3 squared. So 16 and 9. Oh, this is nice and easy. So how far apart are they? 5 what? Not units. Look again. Feet. And the only reason I know it's feet is because they tell me the netting, each line of the net is a foot away from the other one. Okay? Only expect that for these types of problems. But if they just give you points, your units.